Welcome to Arithmophobia No More for a Math Minutes lesson on multiplication and factoring. Here we have a number 12, and we can tell it's a 12 because I have a blue 10 and an orange 2. And today we're going to factor that 12. And factoring just means that we're going to find all the numbers that when multiplied together make 12. And the easiest way for me to do that is to just stick some numbers in, stick some blocks in, find out if it works. If I'm 5, I might throw in a whole bunch of numbers, a whole bunch of blocks that don't work. That's okay. And even if I'm 8, I might put in blocks that don't work. What we're going to do is just find the ones that do work and skip over the ones that I already know don't work. So first we're going to start out with ones, and I'm going to put those in, and then 2s, 3s, 4s. I know 5s don't work, so we're going to just throw in the last ones, which are 6s. 7s don't work. 7 and 7 is 14. So 6 is our last one that will work. And if you're a Cuisenaire user, now I've put up here, for those people who are using them, what it will look like for you Cuisenaire users. And there's something very interesting about these Cuisenaire rods. And if you look, you can see that these are equivalent fractions. Now in Mortensen you can see them, but because of the delineations of the units, it's not quite so easy. And if you wanted to at this point, you could move on to a lesson on equivalent fractions and fractions, but what we're going to do is continue with our work in factoring. So we're back at our number 12, and at this point we're going to pull these blocks down and group them into rectangles according to color. So we have the 6, we're going to pull it down, slide the other 6 over, move it down to the bottom of the page. And I'm going to do this with all of these blocks, so if you just hold on a second, I will get that done. Oh look, I'm done. That was really quick. Okay, so I've pulled the blocks down. We've got 5 different kinds of rectangles, and now we're going to count them. And so we're going to ask some basic questions for each collection of rectangles. So the blues, the oranges, the pinks. We're going to ask some questions. What are we counting, and what do we want to know about what we're counting? And now if you've done this 50,000 times, you can probably skip this part, but if you haven't done this a lot, then I would continue doing it. It's important that your kids really understand what it is that they're counting and to understand what they want to know about what they're counting. What are the relationships that we're talking about? So in this, excuse me, in this first one with the greens, we have 1 over and 12 up. We're counting ones. That's what we're counting. And what do we want to know about what we're counting is what times 1 actually makes the number 12. So if we count up, what 1 times 12 makes the number 12. If we go to the 2s, we can see that 2 times 6, we go over 2 and up 6, makes the number 12. And for the pink ones, we're going over 3 and up 4. That makes the number 12. So if we have 1, 2, 3, 4, and 6. And when you look at the different kinds of rectangles, it's easy to see that while 3 times 4 does equal 12, and 4 times 3 equals 12, we're not talking about the same thing. So one of the groups we're talking about counting groups of 3, the other one we're counting groups of 4. And it's easy to see by color in the way that it's changed. Now we can count them either way, but because we end up at the same place. But one we're counting groups of 3, the other we're counting groups of 4. Now once we've finished making all of our rectangles, we're going to move on to the table of factors and enter some of that information in to our table. And as you can see, I have already entered the information in for the number 12. And we have all of our factors listed there, 1, 2, 3, 4, 6, and 12. So what we're going to do is we're going to start looking for patterns on the table of factors that we're creating. And what we don't want to do is do 1 through 50 all in one day. We don't want to factor 30 or 40 problems all in one day. That's way too much. What we are going to do is under the number column all the way onto the left is we're going to write the numbers in order 1 through 30, 1 through 50, 1 through 100, whatever you think you're going to do, or just fill out one page, 1 through however many you can fit on a page. And you can get this particular file of an Arithmophobia No More on the Facebook group page, or just make one of your own. And so under the number column, we're going to write 1 through 30 or 1 through 25, and we don't have to fill them in order, but we certainly don't want to. So if my child's favorite number is 24, we will factor 24. We don't have to factor numbers 1 through 23 before we get to 24. We can do them however we feel like. But what we don't want to do is factor 24 first on the first line in our table of factors, and then turn around the next day and factor 10, and then factor 15, and then factor 3, because we're looking for patterns, and you won't be able to see the patterns if the numbers aren't written in order. So what are some of the first patterns we could find? Well, let's look. We can ask which numbers have the fewest factors. And then how many factors do they have? Well, we can see here that 13, 17, 19, and 23, besides 1, have 2 factors. And what we want to know then next is, what do we call those factors? Or what do we call those numbers that only have 2 factors? And now we can also look at square numbers. And what do you notice about square numbers and the number of factors they contain? Now we only have the number 16 as a square here filled out. And if you want to know the answer to that particular question, you're going to need to get out and make a table of factors and that it will include 9 and 25 and 36, and see what kind of patterns you can find out. And the next question I would ask, as soon as you know the answer to, or you find this pattern, is, why do you think that's true? Now that we've started looking at square numbers and we've decided that there may or may not be a pattern with the number of factors, or something about the kind of factors that square numbers contain, we want to look at the first square number and the second square number and count the distance between them. And then we want to find the third square number and count the distance between the second and the third. And what do you notice? And then the question would be, is that true always? And can you explain then why that might be true? That there might be a different kind of pattern that would show up there. Now, after we've looked at some square numbers, we can also look at numbers where half the factors are even and half the factors are odd. And if we find the first number where half the factors are even and half the factors are odd, can we find the second one? And then we can count the spaces between those. And is there a pattern? And if there's a pattern, is it true? Does it hold true always? I mean, if you keep counting, how far does this go? Is it always this many apart? Is there a way to predict the next number where half the factors are even and half the factors are odd? Then I would ask some more questions about factors or numbers where all the factors are even and all the factors are odd. And then can we make predictions about what kind of numbers will have factors that are all even or factors that are all odd. So now that we're discovering all of these patterns, we want to record them on a sheet of notebook paper and keep them in our math notebook along with the table of factors. And at first it's probably going to be a little bit difficult for most students to come up with the patterns on their own. That's okay. We're going to not spoon feed it to them. We're going to let them discover this stuff on their own. And if they're genuinely having trouble after we've asked them to find as many as they can, find as many patterns as they can, we can ask some leading questions, and most of them will start out with something like, what do you notice about? And I'm not going to give you more questions to ask. I want you to figure this out with your kids and find the patterns yourselves. And then once the child's a little bit older, 7 to 10, we can start asking questions like, can you explain why this is true? can they give you a mathematical explanation for, say, why does 9, every time 9 shows up as a factor, 3 is always there. And this will lay foundations for them understanding divisibility rules and some other things. And it will also lay a strong foundation for number theory. So what I'm going to recommend to you is that you keep your notebook and then you join us over on the Arithmophobia No More Facebook group, and you can share your discoveries there with us and the other parents and tutors that are there. And if you're looking for more information on Arithmophobia No More, you can go to arithmophobianomore.com. And thank you for joining us today for a Math Minutes lesson.